Welcome back to my YouTube channel Grandpa Mathematics. So we have completed integration. If you know integration, then application of integration and differential equation you will find easier and interesting one. Exercise 8.1. So find the area of the region bounded by the curve y square is equal to x and lines x is 1 and x is equal to 4 and the x-axis. So we know that definite integral a to b f of x dx. This gives the area of the region bounded by the curve y is equal to f of x and line x is equal to a and the line x is equal to b and x-axis. So integral a to b f of x dx is nothing but the area of the region bounded by the curve y is equal to f of x x-axis and the ordinates x is equal to a and x is equal to b. So to find the area of this region bounded by this curve x-axis and the ordinates x is equal to a and x is equal to b, we have to go back to this finite integral. So first you should know what is the value of a, what is the value of b, what is y, and we have to integrate and then we have to substitute the upper limit and lower limit to evaluate the area of the region. So before that, let us see how the curves of parabola looks like. The equation of this curve is y square is equal to 4ax, where a is a positive real number with the vertex at the origin and axis of the parabola along the positive direction of the x-axis. If the parabola is like this, then the equation of this parabola is y square is equal to minus 4ax. On the other hand, equation of parabola with the axis along the positive direction of y-axis. Equation of this is x square is equal to 4ay and along the negative y-axis. So equation of this parabola is x square is equal to minus 4ay. All these parabolas have vertex at the origin. Now, in this problem, we have to find the area of the region bounded by the curve y square is equal to x. So first we will draw the y square is equal to x. And lines x is equal to 1. The equation of y-axis is x is equal to 0 and equation of this line is x is 1 and we can take equation of this line is x is 4. Find the area of the region and the x-axis. So this is the curve and this x is 1. This x is equal to 4 and x-axis. So we have to find the area of this region. Solution. Y square of the x is a parabola. We will mark this A, B, C, D. ABCD is the y square is equal to x, line x is equal to 1, x is equal to 4 on the x-axis. So area of ABCDA is what? So to find the area of this region, we should know the equation of this curve. Y square should be x. So this gives y is equal to f of x is equal to root x. And a is equal to 1, b is equal to 4. Now we can use this definite integral to get the area of the region. So area of ABCDA is equal to integral 1 to 4 y dx. What is y? Y is root x. Root x is x power half dx. On integrating, what we will be getting? X power half plus 1 by half plus 1. X power 3 by 2 by 3 by 2, limit 1 to 4. So this is nothing but 2 by 3. For x, we will substitute 4. 4 we can write as 2 square. Power 3 by 2 minus 1 power 3 by 2 2 square. This is 8 minus 1, 7. 7 into 2, 14. 14 by 3. So 14 by 3 square units. So this is the answer. Okay, we'll go to the next problem. The next problem is find the area of the region bounded by the curve y square is equal to 9x. On the lines x is 2, x is 4 on the x-axis. So again, y square is equal to 9x is a parabola with vertex at the origin as shown in the figure. Here y square is equal to 9x. And y square is equal to 9x. X is equal to 2. Here x is equal to 2 and x is 4 on x-axis. We have to find what is the area of the region ABCDA. Again y square is equal to 9x. This is 3 root x. Here a is 2, b is 4. So this will be 2 to 4. Then 3 times root x dx, and this will become 2. So this is equal to, if we integrate the 3 root x, what will come? 3 into x power 3 by 2 by 3 by 2, 2 to 4. So this is equal to 2 times x power 3 by 2, 2 to 4. Again for x we will substitute 4. 4 means 2 square. So 2 times 2 square 3 by 2 minus x is 2 power 3 by 2. Two into this will become 2 square. The 2 get cancels. 2 power 3 is 8 is coming minus 2 power 3 by 2 is 2 root 2. So what the answer now? 16 minus 4 root 2 square unit. The third problem is find the area of the region bounded by the curve x square is equal to 4y and the lines y is equal to 2, y is equal to 4 and y axis. How this parabola looks like? X square is equal to 4y. So first we have to draw the sketch. X square is equal to 4y on the lines y is 2, equation of x axis y is 0 and y is 2, so this line is y is 2. I can take equation of this line is y is 4. Area of the region bounded by the curve y is x square is 4y and line y is 2 and line y is 4 and y axis. So this area we have to find. Let A, B, C, D. Now x square is equal to 4y is a parabola with the vertex at origin are shown in the figure. To find the area of the shadowed region, area of the region A, B, C, D, A is equal to integral. Previously we have seen integral A to B y dx. That means x varies from A to B. Here y varies from 2 to 4. So how to write this now? Y varies from 2 to 4. Here y dx, here x dy. Previously, the axis of the parabola is along the positive direction of x-axis. Here, the axis of the parabola is along the positive direction of the y-axis. So, for this region, we can write like this. Integral y varies from 2 to 4 x dy. Previously, y dx. X square is 4y. X square is 4y, x is equal to, so integral 2 to 4, x is 2 root y dy. So this is equal to 2 times Integrate root y with respect to y, what will get? Y power 3 by 2 by 3 by 2, then limit 2 to 4. So this will be 4 by 3. Y power 3 by 2, 2 to 4. Then you can substitute the limits. 4 by 3, 4 power 3 by 2. So you can write 2 square. Power 3 by 2 minus 2 power 3 by 2. So that is equal to 4 by 3 times 2 square. It will be 2 cube, 8 minus 2 root 2. So this is equal to 32 by 3 minus 8 root 2 by 3. So 1 by 3 times 32 minus 8 root 2. Or we can take 8 outside, 8 by 3 times 4 minus root 2 square unit. In this problem, we have to find the area of the region bounded by the ellipse x square by 16 plus y square by 9 is equal to 1. So we know x square by a square plus y square by b square is equal to 1 is an ellipse. Is an ellipse with a major axis along the x-axis and minor axis along the y-axis if a is greater than b. In that case, this a comma 0 and this vertex is 0 comma b. And because of symmetry, this ellipse is symmetric about the x-axis as well as about the y-axis. In our problem, we have ellipse x square by 16 plus y square by 9 is equal to 1. On comparing a square plus y square by b square is equal to 1, we get a is equal to 4. 16 is 4 square 4 and b is equal to 3. So that means the major axis is along the x-axis. So this is 3, 4, comma 0. Because this ellipse is symmetrically about x-axis as well as y-axis, we can find the area of this region and we can multiply by 4. To find the area of this region, what are things we require? We should know the equation of this curve. How to get that? That means y. How to get? That we have to get from here. Y square by 9 is equal to 1 minus x square by 16. From there we can get the equation of this curve. And this line, equation of this is x is equal to 0. And equation of this line is x is 4 and x-axis. So now we have to find only the equation of this curve. For that we have to go here, x square by 16 plus y square by 9 is equal to 1. This gives y square by 9 is equal to 1 minus x square by 16. So this gives the value of y is equal to 3 by 4 square root of 16 minus x square. So we have found the equation of the curve. 3 by 4 times. So equation of this curve is y is equal to 3 by 4 square root of 16 minus x square. So now we know the equation of this curve line. Equation of this line is x is 0, equation of this line is x is 4 and x-axis. We can find the area of the shadowed region. Area of the ellipse is equal to 4 times area of shadowed region so this equal to 4 times integral x varies from 0 to 4. So x varies from 0 to 4. Y is nothing but, so I write y dx. So 4 times x 0 to 4, y is equal to 3 by 4 times square root of 16 minus x square. So 3 by 4 square root of 4 square minus x square dx. So now we know integral square root of a square minus x square dx. This is in the standard form. So we can use the formula. So this is equal to 4 times 3 by 4, then integral square root of a square minus x square dx. So what is the formula? X by 2 into square root of whatever comes inside, 4 square minus x square plus a square by 2, a is 4 here, so 4 square by 2 sine inverse x by a, x is a is 4, limit 0 to 4. So this becomes 3 times. Now substitute upper limit, x is 4, 4 by 2 to 4 square minus 4 square. So this will become 0. So this will become 4 square by 2, 8 times sine inverse 4 by 4 is 1. Sine inverse 1 is 90 degrees. That is pi by 2. Because sine 90 is 1. So pi by 2 minus, when you substitute the lower limit x 0, this becomes 0. Again put x is 0. Sine inverse 0 means 0 only will come. 0. So this is equal to 12 times pi square units. So this is the answer. So we know that area of the ellipse is, what is area of the ellipse? Pi AB. So here A is 4 and B is 3, 4 into 3, 12 pi. So 12 pi we are getting.